as a function of potential GDP. Here on the y-axis is healthcare expenditures per capita. The x-axis is potential GDP per capita. It's all in national currency units. So for example, in the US, it's US dollars. Australia, it's Australian dollars. What you see is a very smooth plot in all 6 countries. And the simplest representation of this curve is a straight line fit. I'm sorry. So it's very highly smooth, sorry, aggregate at the aggregate level with R squares over 90%. But the simplest representation is a linear form, which you see here where healthcare expenditures is just a function of potential GDP. The advantage of having a simple linear form is that it can be transformed very easily into expressing healthcare expenditures as a share of GDP, just by dividing through both sides by potential GDP. And what the nice thing about this is that the portion in brackets here, as potential GDP gets larger over time, eventually this term gets smaller, hopefully approaches 0, and healthcare expenditures as a share of GDP eventually approaches beta 1. Now beta 1 is just a slope term, but I just renamed it as marginal expenditure increase to be more precise about what that beta term really means. So what the value is basically saying is that healthcare expenditures as a share of GDP is going to go to, say, 0.237 in the US. Or in other words, healthcare expenditures as a share of GDP will go to 23.7% of the overall economy, very long down the line. However, the MEI model doesn't really tell me why healthcare expenditures might converge to a particular number in the economy. So I turned to the economic literature to see if I can gain more insight. And I borrowed 4 economic theories to create something what I call now the labor wages model. This is the second model of my thesis. And the first model is basically the Solow growth model, which uses a Cobb-Douglas production function, where Solow's growth model estimates potential GDP, which is a function of capital, labor, and technology. Those are the 3 main variables. Now, in the Solow's model, capital is really physical capital.